This is Module 5, Lesson 7. We're still talking about volume. We're going to talk about finding the volume of cylinders. This is a cylinder. A cone, like an ice cream cone. This is like a can of beans or a can of baked beans or something like that. This is a cone like an ice cream cone. This is a sphere, like a basketball. You need to know these type shapes. You will be given a formula sheet to use on these tests. Now, we've talked about the formulas for these. I'm going to go back over them. The formula for the volume of a cylinder is equal to pi radius squared height. The formula for the volume of a cone is equal to 1/3 that, 1/3 pi radius squared height. The volume for a sphere is equal to 4/3 pi radius squared height. Now remember, when we talk about radius on a circle, the radius is halfway across. It's not all the way across. That's your diameter. If you can't remember which is which, radius and diameter, write out the word. Radius, diameter. Diameter is the longer word. It is the longer line. Diameter is all the way across. Radius is halfway across. Okay? Now, first we need to go through and make sure you understand where this term came from. Let me find a cylinder. Well, we'll start with doing the volume of a cylinder. Let's start right here. Okay, and we're going to use what we learned in Part A. We're going to write an equation to determine the volume of the cylinder. Hold on, I'll give you a book and we'll tell you what page that's on. That is on page 129 in your workbook. Workbook page 129. So I'll put that up here. Workbook page 129. Now, let's look at what our formula for finding the volume of this cylinder would be. We said the volume of a cylinder is equal to pi r squared h, or you can think of it in terms of the area of the base times the height. In this case, our base is the two circles. Okay, and the area of a circle is equal to pi radius squared. Okay, so if the area of our base is pi radius squared, and you plug that in here for big B, that means your formula is pi radius squared times height. That's the formula I told you had for the volume of a cylinder. Now, it gives us the radius here. We can plug that in. That would be pi times your radius, which is 4, squared times your height. They didn't give us the height on this one. They just want us to see what would the formula be if your height is h. Volume then would be 4 squared is 16, okay? So that's 16 times pi. They usually put pi behind the coefficient, times your height. That would be the formula for finding the volume of this particular cylinder. Okay, let's look at some more cylinders. This is on page 129, workbook page 129. Now, on this first one, we will do the area of the base thing, but then after that, we're just going to use the regular formula for the volume of a cylinder. They're working with this formula. They're saying the volume is equal to the area of the base times the height. Well, our base, our top and our bottom, is a circle. The area of a circle, the big B, is equal to pi times radius squared. Okay, so if we were to do this, to find the volume, to find the area of this base, that would be pi. Okay, and we're going to use 3.14 for pi. As we all know, pi is a number that never repeats. It goes on and on. This would be 3.1415. So every time we just say something like 3.14, we are averaging our value. We're introducing error on our value that we get because we're not using that 0.1, that 1.5 and everything else. It continues with that. B is equal to, we're going to say 3.14, because that's what we're using for pi. Our radius is 2. That would be 2 squared, which is 4. In your calculator, you put this in. That would be 3.14 times 4 squared, or 2 squared, which is 4, and you get 12.56. So the area of the base here is 12.56, and when you talk in area, it's square units. What's your area of your base? 12.56 square centimeters. What is your height? Your height is the distance between your two bases. In this case, that is 5.3 centimeters. So what is the volume? If your volume is the area of the base times the height, it's 12.56 times 5.3. 12.56 times 5.3. And if I do that, 12.56 times 5.3, put that in your calculator, and you get 66.6. That would be cubic centimeters, volumes in cubic units, right? Let's try this same problem, but instead of doing the volumes base times height, let's use our volumes equal to pi r squared height. Essentially, that's what you did. You just found the pi r squared as your base here. But let's just use the formula here and see if we get the same answer. Because this is a formula they'll give you on LEAP. Volumes equal to pi r squared h. We have estimated pi is 3.14. Our radius is 2. Our height is 5.3. Let's plug that into our calculator. And we've got 3.14 times 2 squared, that's 2 times 2, times 5.3. And that gives me 66.6 cubic centimeters. So see, I get the same answer using either formula. It's usually easier just to use this formula, that we're just showing you where the formula came from. Okay? So on this one, number 3, we're not going to do all of that. We're just going to use the regular formula. Volume of a cylinder is equal to pi times the radius squared times the height. Okay? And in this case, we're going to use 3.14 for pi. The volume then is, we substitute 3.14 in for pi. Our radius, ooh, this is not a radius, is it? That's a diameter. We know if we're looking at a circle, halfway across is the radius, all the way across is the diameter, right? We know that because if you write out the word radius and the word diameter, diameter is longer, so it's a longer piece. So if this is the diameter and we're looking for the radius, we would divide it by 2. 12 divided by 2 would give me 6. My radius is 6. My height is 25. Okay? Let's plug that into our calculators. 3.14 times 6 squared, which is 6 times 6, times 25 would give us 2,826. Volume 2,826, and our units are inches, so it'd be inches cubed. Now let's check ourselves. $2,826. Okay. Now I want to do all the cylinders before we start on the cones. This is on page 132, and this is your formula. Okay, this tells you your formula for this. Workbook, page 132. Please notice, this says the formula for your cylinder is pi r squared h, which is the same as big BH. A is the area of that base. They also give you the formula for the cone, which is 1/3 the volume of your cylinder. We'll get to that in just a few minutes. Okay. This is on page 137. Page 137. Okay. On this one, I'd like to do this as exact formulas. In other words, I want to leave the pi in it. Let's don't use 3.14 for pi. Let's just simply leave pi in our answer. And frequently they do this so you don't introduce error. So we want an exact answer. In other words, don't use the rounding pi to 3.14. Okay? Volume is equal to pi times our radius squared times our height. Okay? So we're going to leave pi like it is. Our radius here is 1, so we plug that in. Radius is halfway across. Our height, our distance between our two bases, is 1. 1 squared is 1 times 1 is 1. 1, that gives me 1 pi for my answer. And what are my units? Feet cubed. Volume is cubic units, three-dimensional. Go to the bottom and let's do this cylinder. Volume is equal to pi times our radius squared times our height. Remember, we're leaving pi like it is. We're not putting in 3.14. We need our radius. Oops, not our radius, because as we remember, if we're looking at a circle, halfway across is our radius, all the way across is our diameter. We know the radius is the short one because if you write radius and you write diameter, diameter is a longer word, okay? So to find the radius when that's our diameter, you'd say 12 divided by 2, which is 6. Our radius would be 6. Halfway across is 6 millimeters. Our radius is 6. What's our height? The distance between our two bases? It's 17. Okay, now we put the numbers into our calculator. 6 squared, or you can say 6 times 6, whichever you prefer, times 17 would give me 612. Okay, so the answer here would be volume is equal to 612 pi. 612 pi. Okay, simple enough. And what are our units? Millimeters cubed. Now, let me see something. Yes, we're ready to do the, okay. This is on page 138. Okay, workbook page 138. Here I'm going to show you how to develop the formula for the volume of a cone. Now, we've already talked about the volume of a cylinder. I'm about to show you something. What if we draw this cone inside a cylinder? Oops, I didn't do too good a job, did I? All right. If we have this situation, what we can see, first, let me write this. So, the volume of a cylinder is equal to pi radius squared height. And yeah, I didn't draw that very good, did I? Okay. Fix this just a little bit. I can't draw. We know this. All right. This being the case, guys, let's look at the cone and the cylinder. If they have the same radius, Okay, the radius is the same. And if they have the same height, because height, remember, on a cone is from the center to the point, right? If they have the same radius, the same height as your cylinder here, I want you to notice what we have done. We have basically removed part of the volume of the cylinder, haven't we? Okay? We're cutting out these two pieces of the cylinder. Look, there's three pieces here. So we're cutting out 2/3 of that cylinder. This cone is 1/3 the volume of that cylinder. So the volume of our cone is going to be 1/3 the volume of this. Pi r squared h. That's where that formula comes from. So let's find the volume of this particular cone. Volume would be equal to 1/3 pi radius squared height. I'm going to say this. Let's say use 3.14 in this case for pi. So we're getting an approximate volume. So your volume would be 1/3 times, let's substitute 3.14 in for pi. My radius, this is my diameter, right? So I would divide my diameter by 2 to get my radius. That would be 7. My radius is 7, so we're going to substitute 7 in place of radius. And my height here is 18.2. Okay, so now let's put this into our calculator. We can multiply everything across and then divide by 3, or you can say 1 divided by 3. I'm going to multiply everything across and then divide by 3. 3.14 times 7 times 7, that's 7 squared, times 18.2. Okay, that equals, and then I'm going to divide that answer by 3, and I get 933.4. The volume would be 933.4, and what are my units? Inches, so this is inches cubed. Volume is in cubic units because it's 3D, right? Okay, let's go back and do a few others of our cylinders that we missed as we were, our cones that we missed as we were going through this because we were doing cylinders. Let's go to this one. This is on page, let's see what it is in your workbook. This is on page 130 of your workbook. I had all these numbers on here, and then I lost that file. Long story. Let's find the volume of this cone. And on this one, we're going to say use pi, or use 3.14 for pi. Okay, our volume for our cone is 1/3 that of a cylinder, pi r squared h. We're using 3.14 for pi, so we substitute 3.14 in for pi. Our radius is 4, we substitute 4 in for our radius. Make sure you don't lose your square on that. Our height is 9. Height is from the tip of the point up to the center. Okay, so if I'm doing this, I'm going to go ahead and do multiply the numbers and divide by 3. I'm going to say 3.14 times 4 squared, which is 4 times 4, and then multiply that by 9. Okay, then my answer, I'm going to divide by 3, and I get 150.7. The volume of this would be 150.7. What are our units? Millimeters cubed, because when we're talking volume, it's 3D, and your units are cubed, right? Okay. If you're not sure, think about this, guys. In here, what we did, we multiplied 4 millimeters times itself twice, and then times 9 millimeters. So you multiplied millimeters by themselves 3 times. So that's millimeters to the 3rd power. Okay? All right. Let's look at the one below it. This one we're going to use as an exact answer. Get the exact answer. In other words, we are going to leave pi in there. Sometimes if you got multiple choices, look and see if they got pi left in there before you start multiplying by things, okay? Volume here for our cone is 1/3 the volume of a cylinder of the same size. Pi r squared h, okay? Now, we're not wanting to put a number in for pi, so we leave it like it is. Our radius is 2.3, so we put that in, we plug that in for this, substitute it. Our height from the center of our cone to the tip of it is 15. Okay, now we do the math and we leave pi out. I'm going to say 2.3 squared times 15 equals, and then I'm going to divide that by 3, and I have 26.5. This would give me a volume of 26.5 meters cubed, cubic meters, okay? Simple enough? Okay. Your formula for your volume of a cone is given right here. It tells you that it is 1/3 a cylinder with the same height and radius, so you know that. Let's see, we have a cone on this page. It's page 137. Let's work it. I want another exact answer on this one. So let's do an exact answer. That means we leave the pi in the answer. If I've got the volume here, you would have 1/3 pi radius squared height. Okay, so we leave pi in there. Our radius is 2.8, and we're squaring that, right? Our height from the center to the tip is 4.3. Okay, let's do the math. I'm going to multiply the numbers together first and then divide by 3. 2.8 squared times 4.3 equals, and then I'm going to divide that by 3, and I get 11.2. Okay, my volume would be equal to 11.2, what was that, cubic centimeters. We've already done all of those. Now we're going to do a sphere. This is called a sphere. It's like a basketball. The formula for the volume of a sphere is 4/3 pi radius cubed. Look, we're not looking for a height because we're cubing the radius. All right? Let's work on this one. This one is our radius because it's halfway across. The answer would be 4/3. And in this case, I'm going to say use 3.14 for pi. 4/3 times 3.14. And 4, our radius is 4, cubed. That means 4 raised to the 3rd power. Okay, there's a couple of ways you could do that in your calculator, but there's so many different calculators out there. I'd hate to start trying to tell you how to do it on your calculator right now. I would prefer just to have you do it 4 times 4 times 4, because we know that 4 to the 3rd power is 4 times 4 times 4. That way I won't be messing you up with different calculators, okay? So when I come to this and I say 4 times 4 times 4, I know there's ways to do it in your calculators 4 to the 3rd. If you know how to do that, that's fine. Use your calculator and do 4 to the 3rd. But because of all the different type calculators you may have out there, I am not going to try to explain how to do it on every calculator here, okay? In this case, what I'm going to do, the way I would put this into the calculator, guys, is I would say 4 divided by 3, or if you can put in 4/3, that's fine too. I'm just trying to make sure everybody knows what they're doing. 4 divided by 3 times 3.14 times 4 times 4 times 4. And if I do that, I get 267.9, okay? 267.9. And that would be, since we're volume, cubic centimeters. Okay? Let's try this one. A cylinder has a diameter of 16 inches and a height of 14. What's the volume of the largest sphere that will fit into the cylinder? Well, you know, the diameter of this ball could only be 14 because that's all I could slide in there. You can't put a 16-inch diameter ball into a 14-inch diameter can. So, wait, it's 14-inch high. You can't put, if it's 14 inches high, this distance here, the biggest it could be would be 14, okay? And so that's the biggest diameter of the ball that you can put in. The volume of that ball is 4/3 pi r cubed, okay? That would be 4/3, and if we use 3.14 for pi, 4/3 times 3.14 times our radius. If our diameter is 14, our radius is half of that, which is 7. 7 cubed. In your calculator, you would put in 4 divided by 3 times 3.14 times 7 times 7 times 7. And you would get 1,436.0. 1,436.0 cubic inches, okay? All they used the cylinder for was to determine how big a diameter you could have for the ball. That's why you didn't have to do any calculations with the cylinder, okay? Now let's do this one. Use the diagram and a general formula to find the volume of the sphere. What if I say I want exact volume? That means I'm going to leave the pi in there. This is on page, let's find this, okay? This is on page 140. Sorry guys, I should have told you that before. This is on workbook page 140. Okay. And that looks like a 6 there, or a 5. I can't tell very well. Really wish they would make their numbers bigger. We're going to assume that is a 5, because I can't see it very well. I'm going to write 5 there. How about that? Because I can't tell. The volume then would be 4/3 pi r cubed. We plug these in. We leave pi alone. And our radius, I think, is 5. That being the case, I only take care of the numbers. 4 divided by 3 times 5 times 5 times 5. And that gives you 166.7. Volume would be 166.7. See, I didn't do anything with pi. It goes down here. And what are my units? Inches cubed. Okay? And 5 says the average basketball has a diameter of 9.5 inches. What is the volume? Round your answer to the 10th place. So that means that you're going to use pi. You're going to use 3.14 for pi. Okay? Volume. 4/3 pi r cubed. That's 4/3. Substitute in 3.14 for pi. If my diameter is 9.5, my radius would be half of that. So you divide 9.5 by 2. You would get 4.75 for the radius. In your calculator, 4 divided by 3 times 3.14 times 4.75 times 4.75 times 4.75, and that would give you 448.7. Your volume would be 448.7. And what are my units? Cubic inches. Inches cubed. Okay? All right. And then this would be number 6 on that homework stuff, which is page 141. Workbook page 141. A spherical fish tank, that means we're looking at a ball, basically, has a radius of 8 inches. Radius is 8 inches. Assuming the entire tank could be filled with water, what would be the volume of the tank? Round your answer to the tenth. So we're going to use 3.14 for pi, because we're rounding. We're not looking for exact. The volume is equal to 4/3 pi r cubed, okay? So we plug this in, 4/3, and our pi would be about 3.14, and our radius is 8. Four divided by 3 times 3.14 times 8 times 8 times 8, okay? That gives you 2,143.6. 2,143.6. And what is that? Cubic inches. Inches cubed. All right? Okay. Now I think that covers all the ones that I wanted. Wait a second. Let me look and see. Oh, no, that covers all of them that I really needed to cover. Guys, I think we're done with that. That covers cylinders, the volume of cylinders, cones, and spheres.